Hi all. Today we are going to discuss about the implementation of multilinear perceptron MLP for a non-linearly separable data. As we all know that an MLP, a multilinear perceptron, is a type of artificial neural network consisting of multiple layers of neurons. The neurons of the MLP typically uses non-linear activation functions, allowing the network to learn complex patterns in data. The major use of MLP are pattern classification, recognition, prediction, and approximation. Here in MLP, we are going to use the exclusive OR gate or XOR gates to predict the output from different inputs. And we are going to plot the graphs for different inputs and outputs. Okay, let's dive deep into the concepts. First of all, we have to analyze the implementation steps or algorithms of the multilinear perceptron for a linearly separable data. The first step to implement the non-linearly separable data using MLP is to initialize the input patterns for the exclusive OR gate. So we have to identify the input features for the exclusive OR gate or XOR gate. So the second step is to initialize the desired output for the XOR gate. That is, we have to declare the required output for the exclusive OR gate. The step 3 is to initialize the weights for the two-layer multilinear perceptron with two hidden neuron and one output neuron. The continuation of the step 3 is to repeat the iteration until the losses become constant and minimal, or is to compute the output using forward pass output, or compute the error and compute the change in weight dw by using backward propagation algorithm, and modify the weight as per the delta rule and append the losses in a list. The last step is to test the input and output data for the XOR patterns. Now we are going to discuss about the implementation code of MLP for a non-linearly separable data using Python. The initial steps of codes consist of importing required libraries such as pandas, numpy, and matplotlib to read the input data and to perform the mathematical calculations and to plot and visualize the relationship between inputs and outputs. The x and y are initialized in the form of array and to get the input in the form of array using numpy database. And the n underscore x is to declare the number of input neurons, and n underscore y is to initialize the number of output neurons, and n underscore h is to initialize the number of neurons in the hidden layers, and lr are used to initialize the learning rate. These lines define the architecture of the neural networks and learning parameters. These np.random.seed functions are used to set the random seed for reproducibility, and w1, w2 are used to initialize the weights randomly, and losses of empty list are used to create a list to store the loss values over iterations. This sigmoid function is used as an activation function. It maps any real value number into the range 0, 1, making it suitable for binary classification task. Next, the forward underscore prop function are used to perform forward propagation. It calculates the input to each layer using the weight matrices W1 and W2, applies the sigmoid activation function, and returns the intermediate values which are useful for backpropagation. And the back underscore prop function computes the gradient of the loss function with respect to the weights. The dz2 is the derivative of the loss with respect to the output of the network. The dw2 and dw1 are used to update the weights w1 and w2. Next, the training loop. This loop performs the training over a specified number of iterations. In each iterations, it runs forward propagation to compute the output, calculate the loss, runs back propagation to compute the gradients, and updates the weights. The next set of lines is to describe the plot of the loss over epochs, showing how the network learns. Next, the predict function. The predict function uses the trained weights to make predictions on new inputs. The last set of codes is used for making predictions. This section tests the network with new inputs to see the XOR outputs. Each test input is passed to the predict function, which uses the forward propagation function and the trained weights to make predictions. The output of the discussed code is to predict the relationship between the loss value and epochs. From this, we can be able to identify the loss function or loss value of the given input data. At last, we have solved the XOR classification problem using multilinear perceptron with the help of Python. Thank you.